Well, everyone's very welcome along to, we had a debate as to what number this is, and we settled on it was probably 9. So you're very welcome along to ReactJS number 9. This looks like a pretty huge turnout, which is super exciting. A little bit of, no, actually, you know what? Welcome, yay. A quick note on the numbers thing. We know that this one booked out super, super fast in like 3 hours. We are going to solve that for the next one, which I'll tell you about right now. No, I won't. I'll tell you about HubSpot first. Thank you very much to HubSpot for continuing to be the only sponsor of ReactJS Dublin. We had a few other sponsors along the way, but HubSpot stuck with us the whole way through. They pay for our time to organize this. They organize all of the seating, security, gin and tonics this time, which I think is pretty special. Yeah, gin and tonics. We are constantly hiring for pretty much every position. My name is McElhinney, by the way. I'm a software engineer here. So if you are interested in working at HubSpot, come chat to myself or any of the people in the HubSpot t-shirts that you see. Also, we do have a code of conduct, which you all agreed to when you signed up to attend. If you have any issues regarding that, please just chat to one of the HubSpot t-shirt people, and they'll be more than happy to help you out. For the first time ever, I think we're like pre-announcing the next meetup. On July 10th, we're going to do our lightning talks again. That was super successful last time we did it. So if you're interested in giving a 5-minute talk to a super engaged, super supportive audience, send us a message on Meetup, or just quickly grab myself or any of the HubSpot t-shirt people. We'll help you out. We'd love to help you workshop your talk, figure out exactly what you would like to talk about. It's always good crack. And I promise we will have solved the seating thing. Tonight, though, let's get right ahead. We have a pretty cool agenda this evening. Firstly, Esdras Portillo is going to tell us about what makes a good React component, and I got a sneak peek of this presentation. I think it's super cool. After that, we're going to have a very, very short donut break, which I'm very excited about personally. And then Stephen McElhinney, who also is a HubSpotter like myself, is going to tell us about GraphQL. We're then going to do our panel, which people seem to like quite a lot. So please join me in welcoming up Esdras.
Yeah, can you hear me? What makes a good React component? That's what we are going to talk. My name is Esdras Portillo. I'm a full stack developer at Sportec. I'm working now with React for about a little bit more than 2 years. And the thing I like about React is this component-based architecture. You have small components, simple, specialized components, and then when you put them together, you have something greater. You create this synergy. You can build very complex applications with a lot of simple components. But while developing these complex applications, it's easy to get the easy path, go to the shortcut, because quality is like a fight against gravity. It doesn't come naturally. You need to mean quality in order to have quality. When you have this illusion to go to the shortcuts, we are actually borrowing time from the future, and we have to pay back this time one day. So would be nice to have some principles, some rules to compare against, to measure the quality in our components. And there are very old rules. They are older than me, but today we are going to look at them from a React point of view. The first one is single responsibility principle. A component has a single responsibility principle when it has one reason to change. It's easier to talk about this principle when we go to the other side. We talk about the multiple responsibilities principle. It always starts with going to the shortcuts. Oh, let's code right away. One big component is easier. Why having all the boilerplate to just put everything in a single file? Why passing props is too messy? So you have always this result. something that is, it's hard to maintain. It's a nightmare in the future. If you change one thing, that has side effects. So you're getting this deadlock of, no, you cannot go further. What is a responsibility? A component should have one reason to change. When we talk about responsibility, is change here is like a change on the implementation. A component is either render list, date peak, fetch weather. When we try to describe this responsibility of a component, if you have these words and or, it means there's more, very probably there's more than one responsibility. Let's say this component gets the emails and shows the list of emails. So and there, it means this component fetch the weather or shows that there is no weather. There is more than one responsibility. And sometimes this is hard to, in the React components, like how come a component only fetch emails? It's not, it should render something, but I like this phrase from Dan Abramov. Remember, components don't have to emit them. They only need to provide composition boundaries between UI concerns. Let's see this bad example here. It's the fetch weather I have here. There's the state, the temperature, wind speeds. The initial are those values. It shows here the temperature, the wind speed, and here it gets from the API. How many reasons here are for change? I can see 2. If we decide to change how, like what information we are rendering, in the way, the order, we have 1 reason to change. And here, if you decide to replace this library or this, to use another endpoint, you have another reason to change. To fix those stuff is simple. It's just make specialized components. This component here, fetch weather, it only cares about fetching weather, omitting here the render, but and the other one is only concerned with showing the way you show, the way we start the weather information. It's much easier to make changes, to maintain. One component doesn't know anything about the other, and then leads to the next principle, that is encapsulation. Encapsulated component provides props to control its behavior while not exposing its internal structure. It's easier to talk about this when you talk about coupling. It's necessary to talk about coupling to talk about encapsulation. Components that have little or no knowledge about other, they are loosely coupled, and components that know a lot of details about each other, they are tightly coupled. Imagine here you have a component, it has its own implementation, its own stage, and imagine if other components depend on this component here, use this component here, internal state or implementation to do stuff. So they are tightly coupled, they are bad, because if you cannot change one without affecting other. But if this component each does its own work and just provide narrow interfaces so these other components can interact with it, they are tightly coupled, loosely coupled. The benefits of loose coupled components are that changes in one component doesn't affect the others. Any component can be replaced, enables components reusability, and they are easier to test. Here, this example, we have a very absurd example here. This control, it receives the div, the Ds, the whole component here, whatever this component is. I am omitting here controls on purpose, because this is what encapsulation is about. You don't know details of other components. But whatever this component is doing something absurd, very wrong, because why it would need the whole state, the whole implementation of this outer component. They are like this couple meant to each other. You cannot and make something in one without affecting the other. If you once you get rid of controls, this other component here is gone as well. We can solve this by providing interfaces like this. This component has now it's rendered the number, controls, uses increase and decrease to change. And controls doesn't care if this other component makes an API request, you update, if it's doing something other crazy or very good, it doesn't care. It just asks, I want to increase and I want to decrease. So those are loose coupled components. Any other components that uses these props can reuse these components. And good components are composable. A composable component is created from the composition of smaller and specialized components, as I said in the beginning. Often I hear there's this, that React is about the virtual DOM, that this is the main thing about React because it knows where to update. But composition is the heart of React. React is very good to take care of composition for us. The way it controls props, the life cycle, it knows where to update. React is perfect for composition. We just need to put the stuff in the right place. And with those, we have a cycle already. We have the single responsibility, the principle that describes how to split the requirements into these small specialized components. We have the encapsulation that describes how to organize what this component exposes, the communication between them, and the composition that is putting everything back together and making something with synergy. A good component is reusable. It's written once, but used multiple times. When we have those three principles, single responsibility, encapsulation, and composable, we already very likely have a reusable component. It's probably that when you respect the other values, our component is already reusable. But we can go one step further and don't repeat yourself. When we see there a lot of files a lot of code is repeated in a lot of different files, you can always do one step more and extract and build one more component. And then this one that is important, don't categorize components based on reusability, because sometimes they're just thinking like, but this is a very edge case. It's not gonna happen in other places. This component doesn't need to be reusable. Or I just saw this kind of component once in the designs. We don't need to make something reusable. But this is very dangerous. There is more than one problem with this kind of thinking. The first one, this opens a precedent. So every time now we are going to create a component, you need to start thinking, should be this reusable or no? I'm gonna check in the designs if there is more than one. So we always have this overload, like why bring this extra work of thinking if it should be reusable or not? And it also, because of this first part here, a reusable component have a single responsibility principle, is encapsulated and composable. The opposite is true. If you go for I'm not going to make a reusable component here, so you are saying I'm not gonna make a component that respects single responsibility principle or is encapsulated because it's the other way. It's true. In other words, you were saying I'm not gonna have a component with quality just because it's not gonna be reused. If the component appears once in the designs, the designer business or whatever, if it's an edge case, the component wants to have quality. So it's very important to don't bring this kind of categorization to components. A good component is pure. We have purity in this sense of functional purity, that a pure component always renders something with the same props. And in functional programming, impure means that has side effects. But I like to put imperative code in the as an impurity as well, because in the declarative imperative paradigm, you have this imperative is code that makes decisions, a code that if this, then that, this kind of go to procedural stuff. It's imperative code makes decision. One example, let's say in this GDPR components we are building, if you have a model there, and then if user selects this, then go to this window or send this message, this is impure. When you bring this kind of logic to a component, you are saying these components will not be reused only if something, another GDPR happens. But you can always put this logic away from the component. The component, you don't know, you send a next to the component, and the next takes care of what is next. The component is declarative, and also functional impurity, asynchronous code, as we saw in the fetch weather, there can be in one component alone, and then the other components as few components with asynchronous code and more components with pure code. A good component is tested. In unit tests, the most obvious benefit is of automation. You don't need to fill a form and press login to see some information there. To see if the message is right, you can automate these props, this procedure using some tools, whatever. But for me, this is not the best benefit from tests. Tests also give confidence to change implementation. It's helpful when you change something in the code, but there's not a lot of code coverage. So later you discover that something that you never imagined happened. And it's also great when you change something and when you run the test, you see tests failing because, oh, thank you, test, saved my life. Because they told you about something that you didn't think about. And tests can be used as a documentation. Sometimes I find myself, instead of looking to the code, to the component code, I go straight to the test file just to see how it's tested, because you see how this component should be used. So it's a nice way to use tests. But the best one for me, the best thing about tests is that tests can tell if your component is bad or good designed. When you test and you find a lot of stuff hard to do, a lot of mocks, and it's to create a whole context, it's very likely you have a bad component, because good components, they are easy to test. And we are never gonna find if a component is easy to test or no, if you don't test them. I have one thing, a lot of the content of the stock, it was like in discussions we had lately in the place I work, Sport Deck, and we are hiring. So send me an email or talk to me later if you want to join our React conversations and code talks. And a lot of this stuff sometimes feels like counter-agile or slow, but nothing has a more profound negative effect on a product than bad code. It drags the team down, it's screwed with deadlines, it gets worse, and smells and rottens with the time. So it's always good to put effort on quality. Think twice and code once. Questions?
Thank you very much. It's wonderful. Yeah, so we have we have about 5 minutes for questions. The way we're going to do things is we're going to run around with a microphone to make sure that everyone can hear you. Please don't ask your question or speak until you have a microphone. So does anyone, and we're also going to have a panel at the end. So if you come up with any questions later, feel free to ask them then. In the meantime, though, does anyone have any questions? Actually, I have a question. So when I was looking over your slide deck when you sent it to me earlier, it struck me that what this deck is doing is kind of teaching us a whole load of things that we would otherwise have to figure out for ourselves by making mistakes and just like making our lives absolutely awful. If you were to like put a number on it, how many like weeks of React mistakes have you just saved all of our attendees?
It's hard to tell, but I think it's like, as I said, these values, they're very old. It's like decades of improvement. So maybe it's decades of work. Once I saw a guy saying that the average increase of developers it doubles every 5 years. After 5 years. So if you do the math, half of the developers today have less than 5 years experience. So it means that there are not enough teachers. Yeah. So it's good to stick with these values to save time to not figure out stuff that people figure out for you before.
I agree, that's great. So do we have any questions? Cool, okay. If anyone does come up, as I said, we're gonna have a panel after the second talk. In the meantime though, we need to do some laptop switching. So please join me one more time for thanking Esdras for speaking for us today. So, as I mentioned, we now have a super fast 5-minute donut break. So the aim is to go, get a drink, get a donut as fast as you can, and then quickly get back here within the next 5 minutes. See you in 5. Okay, let's get going. First things first, I have to apologize to Stephen for misstating what the topic of his talk was. He is in fact going to talk about React Apollo, so I'm very sorry about that, Stephen. As I mentioned at the start, we are doing those lightning talks. A few people have come up to me said they'd be interested in doing them. Come chat to me if you think you will be. They're always a lot of fun. They're super fast, great way to get experience and to talk about a cool project you've been working on. But in the meantime, please join me in welcoming Stephen.
Cool. Okay. As Keith mentioned, I'm going to talk about React Apollo. The slide say that it's about GraphQL. I have made an assumption that at least you have a bit of understanding of GraphQL because GraphQL itself is a topic. So this is a bit. So we'll do a very brief intro on GraphQL. It's basically to scratch the surface of what it is. We'll talk a little bit about ApolloClient, framework developed by the Meteor.io JS team, Meteor.io development group, which essentially interfaces with GraphQL servers. We'll talk about the React Apollo components on top of that. I'll do a quick demo, very dry demo. It's about 5 or 6 minutes long. Broken all of Esdras' rules, so. And then we'll leave some time for questions. So GraphQL, it's a query language and an SDL. An SDL is a schema definition language. So you'll see it kind of looks like this. You have a GraphQL layer and a database behind it. You query nodes on that database and it turns you data in that format. The definition language itself allows you to define the schema as in what properties each entity in the schema has. And it looks something like that as well. It's developed by Facebook in about 2012. It was open sourced and publicly released in 2015. So since then, there's a lot of kind of community groups that have started up like GraphQL. I know there's some kind of GraphQL as a service companies like Scaffold.io. So yeah. What GraphQL solves for quickly is overfetching. So overfetching is essentially getting too much data on a round trip. So you're getting more data than you actually need. So in traditional REST interfaces, I'm sure you're all aware, if you try to query a REST API, you want a small subset of information, you essentially get everything that the REST API gives you, and then you have to mutate that on the client. So GraphQL essentially only gives you the information that you query. It also prevents things like multiple round trips. So if you have, you need information from 2 different sources within the schema, you can define that in your query. Otherwise, you have to, ordinarily in REST API, you'd have to call 2 different endpoints, aggregate the information, and then make that available to your client. And one of the best features about it is the API versioning maintenance. You don't need to do that. add new fields. GraphQL, they're immediately available to your developers whether or not they want that feature. So that's a nice feature of GraphQL. I mentioned before about GraphQL. These are probably one of the community groups who are most active in the GraphQL as a service kind of framework. They're very opinionated. It's an all-in-one backend as a service for GraphQL. They base it on Apollo server. We're talking about ApolloClient, but there is like a GraphQL server layer as well called Apollo server, and they do promote kind of a lot of the Node.js environment stuff like Express. They do have a lot of CI/CD built in. They're very heavily reliant on Docker. One of the nicest features about GraphQL is that they provide this playground interface where it's essentially deployed to your server. You can test out your queries. You can make really simple queries through a GraphQL interface. So I think you might have come across GraphQL to your API GraphQL before. And then ApolloClient, as I say, is what we're going to talk about today. ApolloClient is a GraphQL client primarily JS, but they do support native. They have other JS apart from React, so they have Vue, Angular, they have Meteor as well. And some of the stuff that it supports also native on iOS and Android. Some of the stuff it supports are things like caching and optimistic UI. Caching essentially, TLDR and caching is if you're retrieving records from your client and you want to cache them in the client layer, you need to essentially make sure that they're primary keys. So, unique ID in the database. And ApolloClient takes care of all of that for you. The optimistic UI is a really nice design pattern. So essentially what happens is it simulates the results of a mutation before you get the response from the server. So it's used a lot in progressive web apps where you might have somebody kind of enter a form. That's not mine, is it? I'd be Roy Keane. You might have the UI render before it gets around to a response from the server. So the user thinks something has happened, and then what happens is when the response is received, it resolves itself. So it might have failed, or it might have a different response, and then the UI updates as a result. Pagination and prefetching are also done in ApolloClient. So if you have record sets with more than 100, 200 records, you can paginate through them. You can prefetch, if you have a paginated record set, you can prefetch them in advance so that you're kind of speeding up performance on the client. And it also has a developer tools panel for Chrome, which is really nice to use. React Apollo is the React implementation. I feel like I've cascaded down here. So React Apollo is the React client interface for ApolloClient. So it can be used a couple of different ways. You have like these component enhancers. They're very similar to higher order components. And then within the library itself, you have these exposed components, custom components like query mutation. And I'll show you some of those in the demo. You can do it one of both ways. I'll show you examples on the next 2 slides of how you would do it in either way. One of the really nice things about React Apollo is local state management. So there's a library called Apollo Link State that they promote. It's kind of developed by them. And effectively, it negates the need for any other state manager on your client. What you do is essentially in your schema, you can mark some of your schema entities as available on the client and cached on the client. So you can literally manage small parts of your state or your entire state on your client using Apollo Link State. So that's pretty cool. React Apollo, this is the component enhancer example. So you have 2 libraries here, GraphQL, which is available through React Apollo, GQL, which is from GraphQL Tag, which is actually a library managed by Apollo. So essentially you have your component here, you call your GraphQL library, you pass it a GQL query, and essentially what it does is it makes the results of that GQL query available to your component on the props. So there's a couple of different prop values it adds. It adds like your loading state, whether or not there are errors from your query, and then the data that's returned as a response. And there's other stuff that it adds, like if you want to refetch your query, it makes a function available to refetch your query quite easily. This is the custom component example. So it's a little bit more complex, where you'll have your custom query component here. You'll have like, this is render props. I don't know if you've seen render props blocks, but essentially you have an isolated block here. First parameter is the props from the result of the query. And then you can actually essentially just create
component with nested DOM inside it. One of the things I will say about render props is we don't really use them because we like to use a lot of pure components, going back to what Esdras said. And if you use a render props, the shadow props comparison on your render props function will always return false. So you're not getting the value of pure components in terms of like UI performance. So you just need to be careful if you are using this structure. And having said all that, I actually did all my demo on this. So yeah, so just examples of where you'd use one over the other. So the component enhancer or the component enhancer, the higher order component, you might use that where you might have very, very simple queries because it's quite easily readable. You can actually just stick your graph query in this context here, and you basically Apolloize or graph queryize your entire component. Where it becomes kind of unwieldy is when you have large, big, kind of complex queries. Then you need to switch to something like a more componentized structure using the custom components. So we're going to kick into a demo. Hopefully this works without any hitch. So I know you all love code. That's why you're here. Let me see. So underpinning all this, we're using a database layer called Prisma. So I didn't need the full Apollo server end-to-end suite. I don't need the kind of the server layer. All I need is the database. And if you go to prisma.io, they were really good kind of backend as a service GraphQL database that you can deploy to any kind of AWS type environment, or you can deploy it locally using Docker. So I have a local Prisma service, I think, I hope, running. Never checked that. Actually, I'm using a public one, so I'm fine. And then I built a really, really simple app. So what I'll do is I'll go through how to set up a React Apollo app from scratch. There's nothing private or sensitive in there, so I don't mind showing you my end variables at this point. So our bootstrap is really, really simple. Like, don't mind all this stuff here. This is just style components. Who likes style components, by the way? Does anyone? We got some style components now. Yeah, style components, if you haven't checked it out, it's really cool. Yeah, sure, can you? Yeah. Let me see. Control, what was it? Shift and plus, isn't it? Happy? Good. So this is the bit down the bottom you really want to see. So it's a higher order component to create like your Apollo provider. Apollo provider is essentially like your Redux provider. You're basically making Apollo available to your entire app. So it's a wrapped component. The client itself is very simple, it's very straightforward. I have two clients here. One is what's called Boost. Boost is Apollo's kind of very simple, get it up and running, server only, very minimal configuration client. So if I just show you that basically, it's essentially just a client component with a URI. And once that's configured, it's configured globally for your app. The other advanced component is very, very advanced. So I don't want to take you through all this, but one of the differences between the minimal configuration and the advanced configuration is that there's a lot of kind of stuff in GraphQL that you don't get out of the box, like subscriptions. Subscriptions I'll talk about at a later slide, but that's a really, really useful feature of GraphQL. So to configure your advanced client, this is what you do. I'm not going to take you through all this. This is very, very advanced. So your minimal configuration, you have your Prisma endpoint, which is our publicly hosted GraphQL server. I'll show you the playground in a second. You have a client, and then you just expose the client. And this is the client that we use on the app. And it's a provider with the client prop, and then call this. And then the app itself is this. So very simple React components. Again, it's not pure, apologies, that's just very simple state. We're using style components here to build a UI. Show you the UI in a second. Actually, I'll show you now. That's not fair. Hopefully this works. Yeah, we're good. Okay, of course it's about marvels and all that kind of stuff. So very, very simple UI. You have all your movies on the side, which are already in the GraphQL database, characters and some filterable movie content there. So the way this is set up is a number of different queries. What I've done, and I think it's a really nice pattern for GraphQL, is to essentially separate your queries out. I suppose this is single responsibility when you think about it. In order for me to make these reusable, I put them into a separate file that I can reuse then across a number of kind of views. So this is a really simple GraphQL query to get movies. I then expose that. It's a private variable at the moment, but I expose it by nesting it in a GraphQL query. And what I'm saying here is send me back an React Apollo query using the query syntax from above, and use the render props to append the result, or to append the result as props to any children of that component. So if I go back to my view now, in our components, we have a movies component. This is, don't mind all this. This is the movie info component that shows the movie info, and you can see the destructured property here in the in our props argument, which has all of the Apollo available props for a GraphQL query. We're not using network status. If we want to determine whether or not a query is loading, we use the loading status. If there's an error, we return an error. Otherwise, we use the data. And this here is essentially just iterating through the movies and creating an iterable div with just the movie name and the movie year. And that's essentially what you see here. So if I wanted to add a new movie, come on, think of another MCU movie. What one have I missed? Which one? Ragnarok, I haven't, no. When was that? Last year? So 2017. Now, subscriptions will allow me to, if I posted this, it would actually update the UI for me, but I have to manually refresh. Apologies. Not very React, but however. What's happened here in the background is it's posted it to the GraphQL server, and it's now available here as a, oh, look at that, my array ordering is perfect. Anyway, so we have a filterable list here. And the nice thing about this is, as Esdras mentioned in kind of single responsibility, I'm using a single query, but then passing filters to it each time. So it's a pretty, I like it as a design pattern to separate all your queries, because otherwise you're going to have big, massive monolithic view files with nested GraphQL. And if you have to change more than one thing in it, you're breaking all Esdras rules, which is not good. So that's a really, really simple contrived example. I have this on a GitHub repo. It took me probably a day to do this, but there's lots more stuff that you can do with this if you want to download it and play with React Apollo. Set up, you have everything there you need to set up your own instance of GraphQL. It's all in the README, so I'll make that available to everybody. And the underlying, I just want to show you quickly the playground for this. So when you deploy GraphQL, hopefully this works, yeah. So when you deploy a GraphQL server locally, actually that's the wrong, it's fine, it's running locally anyway, hopefully. This allows you to run any query that you want. So for example, our movies query is get movies. I just want the name and the year. And there you have a list of movies with the year. Yeah, this is a really nice feature of Apollo. Prism, this is a feature of Prism actually, Playground. Okay, so that's our demo. As I say, there's lots more, I had to run through it, apologies, but I have lots more information in the GitHub repo if you want to pull it down and reference it. I'll get back to the presentation. So a couple of the things that I haven't talked about as part of ApolloClient and they make available out of the box. I've showed you the advanced configuration. Subscriptions is a fantastic feature whereby you can actually register using WebSockets. On your client, you can listen for mutations on your GraphQL server. So you can set up a subscription on your UI. Anytime a record is added to your GraphQL server, you can, just count time while I change my notes. You can basically update all the connected clients on your website, any WebSocket connected client. So a simple example of that would be the one that I showed you. Once I posted a movie, I should have had a subscription running that said every time a new movie was added to GraphQL, update the UI. One of the ones, common use cases, I suppose, is chat. So if you have a GraphQL chat database, you want to obviously update clients every time there's a new chat message sent to the GraphQL there. Middleware and afterware. Middleware essentially runs before the request to the GraphQL layer. So a common use case for that might be authentication or session management, session checking. So afterware essentially runs after the request from the GraphQL layer, but before the request is sent to the client. So in that kind of interim between GraphQL and ApolloClient, that's where your afterware. A common use case for that might be kind of, you might do session checking on that as well. If a session is expired before a client has received the data, you might want to do something around that. Query mutation and batching, straightforward. Like you don't get the batching, mutation batching as standard in Apollo Boost, so you need to set up how the Apollo server handles that. And a really, really nice feature is schema stitching. So schema stitching is take one GraphQL service through configuration, point it to another GraphQL service, take information from that GraphQL service, and manually stitch it into your own schema. So that's nice if you have a load of different kind of independent GraphQL instances and you want to kind of stitch them all together. And that's my talk on ReactJS. Any questions?
So same rules apply for questions. If you've got a question, throw up your hand. Please don't ask it until we get a microphone to you. Got any questions? I've got a question.
Go for it.
Yeah, I'm prepared. Firstly, before I ask the question, do we have any GraphQL stuff in the product?
In the product, no.
Okay.
No, I don't think we do. So.
Have you like worked from? So I'm mostly, entirely in fact, work with REST APIs. Have you worked with migrating a REST API to a?
I have actually, and it's funny you should ask that because one of the most common use cases is actually GraphQL interfacing to existing REST APIs without replacing the REST API.
Okay.
So in GraphQL have this product called GraphQL Yoga. It's a freely available, community available server. And essentially what that allows you to do is write your own resolvers. So if you could write a GraphQL interface to a REST API, query the REST API, return only the information that you need from the REST API using a resolver, and then essentially cache that information on the GraphQL layer so that you don't have to go to the REST API. If it's uniquely identifiable information, you don't have to go to the REST API each time. So a fairly common use case is existing database exposed to a REST API, new information to a GraphQL driven database, merge the two of them together, but not over time, obviously, kind of phase out the REST API, make that information available in the database. But it's a fairly common use case.
Cool. And just out of interest, subscriptions, do you mean like, is that long polling? Is it WebSockets? What's going on?
Under the hood, yeah, it's WebSockets under the hood, yeah. So they have their own library called ApolloClient, which has server event gateway side of it. So it sits on the server layer and essentially just listens for mutations on the GraphQL layer and broadcasts those events. And the same library works on the client as the server. So you essentially tie your client up using ApolloClient to listen on the pre-configured WebSocket for any mutations too. You can subscribe to all sorts of events. So, yeah, very cool.
We have any other questions? We have one over here. Wait, hold on. Let's get a microphone to you, please. Okay, sorry, we'll come back to you if that's okay. That's a question up here.
Hey, thanks, Stephen. You mentioned that the dev tools were pretty nifty.
Yeah.
As well as, do you have that set up?
Actually, don't actually. I was just thinking that on the way up. It's not too dissimilar to Redux. So the Redux dev tools, it essentially allows you to inspect from the provider down. Shows you all the props on it, and yeah, I suppose I probably oversold it. It's not as cool as I probably made it out to be. It's Redux. It's Redux tools on steroids.
Cool. And we have a microphone just behind you here.
He just said testing, and I'm afraid of what this question is.
Just testing, like
just testing.
Yeah. Like, if you've got nested components that are connected, like, what do you do?
Yeah, it's a really good question. Like, so I know that Prisma has a layer for testing queries themselves. So how I would kind of put it back on you, how is testing standard React components different from testing this kind of ecosystem? You're testing, talk to me, what exactly do you want to test with your ecosystem?
Let's say you've got, maybe you don't, maybe not, you wouldn't be doing that unless you're rendering the entire, you'd be doing shallow rendering, so you wouldn't really care, I guess. But if you weren't shallow rendering, if you're rendering the whole tree of components, and you have a component that inside it has a component that's connected that has a query on it. Let's say, sorry, I'm talking about Redux.
Yeah.
How can you like set it up so you can mock data and provide?
Yeah, I have seen particularly on GraphQL tag, the library that Apollo make available, they have a mock API implementation or a mock library implementation of that. So you can mock query results, but yeah, it's difficult. You won't successfully do full end-to-end testing on it, I suppose, unless you had an entire mock data layer that you had readily available.
That's what I was thinking.
Yeah.
Someone created it, does it exist, but how much?
It doesn't. No, I don't think. I haven't come across it yet. So we're not at that stage. Or I suppose if we were a test-driven development, we would have started already at kind of looking at our app and trying to define our test, but we haven't. We're only playing around with this stuff at the moment. So when we do find out, I'll come back and tell you.
Cool. Do you have any other questions? Check, throw your hand up.
No.
Great. We're about. Oh, wait. You just snuck in there.
Yeah. So with GraphQL and fields, it handles adding fields all right, but what if a field changed or was removed?
Field was changed. If the client, so what would happen in a traditional REST API environment there would, well, it depends on how closely bound to the view your data source was. But the GraphQL, if a field was removed, it depends on the implementation. So if it was removed from the database layer, you would cause errors, okay? But if we're talking about this, and I just mentioned to Keen about this resolver layer in the middle, if the resolver is set up to handle null values for fields that don't exist in the database, it's essentially fine. It might break the UI, but it won't cause catastrophic failure because you're returning null for fields that don't exist on the database layer. But if, in my example, I'm pointing directly to the database, if I remove that field from the database, at query, if I queried and requested a field from the database that didn't exist, yes, it would break. So I suppose the TLDR there is if you want that level of control over, you know, whether or not the UI breaks from backend updates, use your middleware layer, use your resolver layer to handle that. But you shouldn't really have to refactor your entire code base or refactor your queries to handle scenarios where fields have been deleted.
Cool. Okay, any more questions? Great, so, oh, no, let's do it, let's do it. Let's get a mic. If anyone has another question after this, please put up your hand for like a fraction of a second before I try and close it. Thank you very much.
So is there any situations where you wouldn't use this with a reactive app?
Say again, sorry.
Like, is there any like situations where you wouldn't use like GraphQL Apollo with a React app?
Oh, so examples of where it's not suitable. I don't know. I don't like so the server-side rendered aspect of it is it's a bit in its infancy. So if you're relying on server-side rendering for React, if you're using like Next.js or something like that, the Next Apollo library for that is not great. It doesn't handle a lot of the queries in the server without you writing a load of code. So I would kind of try and if you really need SSR, maybe look at an alternative or be prepared to write a lot of code with it. Yep.
Is it possible to flatten a response? For example, movies with names.
Yeah.
And then like instead of return like a JSON of movies with names, return just like an array of strings with the name of the movies.
There is two ways of doing it. There's one where you update your schema with what's called connections. So you can add connections for everything on your schema, and you can add like GraphQL obviously supports edges and nodes, and I don't want to get into a kind of philosophical debate about edges and nodes, but that's a way of doing it at the database layer. You can also do it at this resolver layer, which is the middleware layer. So you get the request, you get the response from the GraphQL layer, you flatten it at that point and you make it available to your client. If you can, stay away from that, because that means you have a separation concerns there where you have to manage this as well as this. If you can get away with managing it just at the database level, do that. Have your schema tied down as kind of tightly as possible so that you don't have to, you may not even have to implement a middleware there.
Cool. Thank you very much. That was really informative.
Thank you. Thank you, Scott.
Cool. So now we're going to move on to, I think, one of the more popular sections of ReactJS Dublin, which is our panel, where you can ask the speaker and maybe me, if you think I know anything, which is doubtful, any question that you possibly have about React. So please join me in welcoming our speakers back again. Hey, we get to sit down this time. So as we, if you have a question, please throw your hand up. We'll get a microphone over to you as soon as we possibly can. Something I'm working on today is, so I'm just upgrading to React 16, which has like resulted in me having to upgrade Enzyme as well for our testing from whatever the old version of Enzyme was to whatever the new version is. And oh my God, is it, have I just written my tests wrong? Have either of you two done this?
I haven't, so I'm going to point that out.
Like, why is it making my life no fun?
What? Sorry.
So I just went on a rant. I'm very sorry. Have you upgraded to the new version of React and Enzyme?
Yes.
Was it easy?
It actually wasn't me, but we as a team. But I think it wasn't easy. A lot of.
That's very good to hear because it's not easy for me. Anyway,
what's your pain points with Enzyme at the moment? What's difficult about the previous version of React versus this one?
Oh, it's not necessarily anything different or difficult about Enzyme. The API has just changed in like non-obvious ways, and they've documented it very well.
Yeah.
I'm just at that point in the I started it like 2 hours before this started, so I was already stressed. And so I feel like maybe tomorrow I'll be able to sleep on it. And be like, you know what, this is super easy. But yeah, I don't know. I felt like I wanted to rant about that.
That's good.
Yeah,
this is the forum for that.
It is the forum. I can just let all my emotions out. So does anyone else want to let their emotions out, or is it just me? Any questions? Anything to do with React? We just get to sit here, I guess.
I think
that's pretty exciting.
Oh,
let's get a microphone to.
For me, surprise, Lamberto.
Hi, so this is a question for Stephen and React Apollo. So I was just wondering if, in case your application is using Redux as a state management, is there a way to make it work with Redux? And have you encountered any scenarios where this?
I haven't, but theoretically you can if you use compose components. So it is a case of just, there is a higher order component enhancer for Apollo. So I think it's just a case of composing from Redux to Apollo to your app, and you're passing your store the whole way down, you're passing your client the whole way down. But my ask of you, or my point back would be, if Apollo can already do local state management, do you really need to? But you can, of course, manage both of them. It's just then you'd have to decide what goes into Redux store, what goes into Apollo cache, for example. So
I'm wondering, for example, if your application fetches from multiple data sources, one of them being on GraphQL, so Apollo, and another one being like a normal REST
API. Yeah, that's probably a good use case for it, I suppose. Yeah.
Cool.
Yeah.
Thank you.
Cool. Anyone got a question? Throw your hand up. Right over here, as far away as possible. Run.
Cool. Sorry. So yeah, you were saying there that you were trying to update to React 16, and you found.
You about to shame me now? Is this?
Oh well, no, it's kind of interesting because I've had the good fortune to jump from React 15 code base directly into a React 16 code base without having to go through the toil of actually upgrading. So you said it changed in non-obvious ways. So it's kind of interesting, finding out what those non-obvious ways were. Because
so it's not React I'm having the issue with. It's just the Enzyme. So that's the
testing library. Enzyme.
Oh yeah, no, React's grand. Let's go. That's easy. They've like written tools, so I don't need to even think about upgrading. It just works. But yeah, Enzyme's API has changed in some, I must say, very well documented ways. It's just we have like hundreds and hundreds and hundreds of tests, and like 10% of them are broken. And I'm having to go through them like one by one. So
that makes
it's sore. It hurts.
Yeah, cool, perfect, thanks.
Any more questions?
I want to ask you a question.
Oh no. Okay.
Oh no, I have a mic. I realize. I have the power.
Yeah, we can't stop you.
Yeah. Are you using Context API, or have you plans to use Context API in the near future?
We have 0 uses of that in our app.
Okay. Is it because it's completely Redux, or?
Yeah, we're fully Redux.
And
we've built like our own caching there, but like that sits between our API clients and Redux, but it's effectively entirely Redux as far as the app is concerned.
I'm curious, like, what about in your space? Are you looking at context API at all? As a,
Just read it.
oh shit, that died. That question.
Does anyone have opinions about context API? Oh yes.
Hey.
Yep.
Yeah, so me again. Hello. Yeah, so I guess it's one of those things where up until about 6 months ago, even before the new API came in, I would have been like, oh no, never use context API, whatever else. But we came across a couple of challenges in the company I was working for at that stage where context APIs made perfect sense. And someone who was kind of relatively new to React was like, oh, well, I was going to use context API because, it seems like it would work. And it's like, oh no, you never use context API because, they warn you against in the docs. And it's like, oh, but you see, if it works this way, it's really useful. And I thought, okay, actually, that's actually pretty fair. Good point. And then they.
Sorry. What's like for the people who aren't aware, what's like the 30-second explanation of what it is?
Oh, context API. You have more than 30 seconds. Essentially, so context API has existed in React since day dot. But as I don't know your name, sorry, but as
Richie, sorry.
Richie mentioned that there was a global developer warning that essentially prevented you from using it because it was almost essentially eternally in beta and wasn't reliable enough. But funnily enough, a lot of Redux implementation is built on context API. So with React 16, they made it quite stable. Context API allows you to set, have a wrap component, which is essentially context for your entire app. I'm right in saying it's immutable, isn't it?
I don't know.
It is immutable context API.
As far as I know, yeah.
Is it? No.
No. Pass data to
yeah, so
without passing through props.
Yes, but can you change?
You can't mutate it from a lower level.
You can't change context from a lower level. So you can't change the context. If you set a context at the stop,
Can you change the data passed in, you mean?
at the higher level.
Yes, you can. You can have different providers.
Come on.
You can have providers nested in this tree or hierarchy, and those providers can override the value provided by another provider above them. Is that what you mean?
Override it, but can they essentially change the parent context?
No, I mean what they do is they just provide another piece of, they say, okay, for a key team, instead of using the parent value for team, I'm going to provide you my own value for team.
Yeah.
So
you set context, you essentially override the whole way down. You can't.
Yes, your children from then on will have that one set.
So one of the use cases we have for it internally here is like to set, we have like React apps which sit within web pages. We have people who manage a lot of the content of the React app from outside the web page. So what we do is we pass that in via data attributes to set a context at the top level and allow them to override a lot of the capability of the React app. Configuration options, localization strings, for example, things like that. That's how we use context API, but I wasn't sure whether it was immutable, whether a nested component could actually change the parent context.
Well, that's the new API. I don't know about the old one. I've not looked at it. I had no interest because it was the warning.
Yeah.
But I was just wondering if other people have used it for like large-scale dependency injection. Probably not, I imagine.
Probably.
No? Like a service locator kind of pattern for Java? No? Java?
Yeah. So the
better?
only thing to your point there, can you actually change the data that you're providing, say in a way? The answer is yes, if you actually provide ways to change it.
Yes.
So essentially, like you could say, think about like a theme provider, right? So you could say, okay, I give you the theme, and anything that consumes that somewhere inside in your app could just use the value and say, I'm in black or white or whatever it is that your UI is. Or alternatively, you could also provide like a set theme, right? And there could be a button somewhere that says, I'm going to set the theme to this thing or the other. So whatever those things are, is up to you. And I guess actually the React docs have done a good example at explaining that now. Like when they first launched the context API, it was a bit unclear around how you would actually go ahead and like provide functions that would allow you to change that state. And the recommendation that they're giving today is that you would store your functions that are the setters within your own state as reference to your own component, and then essentially anything could consume them and change them.
Okay. Yeah. That's very good, actually. That's a nice pattern. I like that.
Do you use Redux Tonk or Saga or something like this here?
We use Saga.
We use Tonk on our team.
Yeah.
Tonk?
We own a project which uses Saga, but I haven't really dug into it all that much. What do you use in your teams?
Dunk.
Dunk, yeah. What do we like? So, well, what do hands up if you use Redux, I guess. No. That's pretty good. And Saga. What do people think? Like, what do people think of the pros and cons of like why did the people who chose Saga choose Saga? Because I guess Dunk for a long time has been kind of the default. Yeah. I'm really interested in hearing if anyone has like some reasons or strongly held opinions. All the better, the stronger the better on this.
We want you standing up, waving fists.
If you're not shouting by the end, I feel shortchanged. No, we just all kind of just did it. We were just like,
sounds cool.
Sounds cool. It sounds better than that. Thunk sounds rubbish.
Yeah.
Thunk. No, it's that Saga. Yeah, that's good. Anybody got any other questions? Topics of conversation? Interesting stories.
Would you ever use GraphQL for a real-time application?
With subscriptions, yeah.
So the question was,
yeah.
Would we use GraphQL for people who can't hear? Would we use GraphQL in real time?
Yeah, like it's not just a bolt-on subscriptions; it's part of the core GraphQL layer. Is that what you're asking, or?
No, but I mean like the app, basically like trading application. You know, it's a heap of such real-time information.
Yeah, that's a good point.
Kind of awkward to get that.
It is and it isn't. You're kind of the only constraint you have is on the concurrency of your database rights and whether or not your WebSockets can hold up that amount of traffic going to your clients. Because it's WebSockets on this. There's a WebSocket server installed for you, and there's WebSocket clients as well. So you're only constrained by that pipeline. How is it any different to like a standard trading app, which probably relies on WebSockets through a?
It's more like GraphQL seems to be optimized for REST API replacement for data retrieval, and then that's kind of it. And you can do a little bit of updates on the side, but it's not really like changing amounts and like dates and stuff like that really quickly, and changing subscriptions to get new prices in for when you change
I know what you mean,
substantial model information.
Yeah, you are right in that. I've never seen one anyway. I've never seen, like in the wild, I've never seen somebody using a GraphQL for that level of information, but I would put it back on you. How is it any different to a standard, say, stop trading application that uses WebSockets under the hood for broadcasting updates to its UI? You're only constrained by the server that's processing the number of transactions per second. In this case, your database is your GraphQL layer is agnostic to your database. There's lots of database formats supported, mostly relational. I have to admit, there's not really a lot of NoSQL support for GraphQL. Primarily Postgres, MySQL. There is I can't remember the other one. But if you're only constrained at the database layer for how often your database writes your pipeline to your WebSockets, and then how many WebSockets you can connect to a client at any one time. So it's the same kind of constraints that you have in standard single page application that maybe uses long polling or things like that.
Okay, cool. Just curious if you thought it was a crazy idea, that's all.
No, it's not. I think you will have to optimize your schema. Like your schema will have to be optimized no end. You'll have like lots of, I can show you the schema, very simple schema with it's a very contrived example, but you set up relationships between all of your schema entities. In that example, you would have a lot of connections, and it is the responsibility of your database layer to understand those relations and to be able to process those transactions really, really quickly. Notify your WebSocket GraphQL layer, which notifies any connected client on your WebSocket, which obviously takes the client updates. But you're only constrained by the technology all the way down the pipeline. Does that make sense?
Those GraphQL use the same kind of HTTP response as REST, like normal REST, like HTTP 200, 500.
I think so, yeah. I think it
and would be like authentication handled by GraphQL as well.
You can, yeah. So on the GraphQL GitHub repo, there's lots of examples for things like authenticated user payload. They have a really good example for getting gists. So from GitHub repos. So you obviously need to GitHub OAuth there. That's a really good example. Essentially what they do is they create the schema which has an authentication payload. So you have to authenticate the client first, pass your authentication across. It queries your schema with your authentication payload to ensure that you can actually access those records. But it's on the GraphQL GitHub repo. Check it out. It's really good.
Cool. I think we're going to leave it there for this evening. We still have another half an hour or so before we need to leave. So we have a wonderful balcony and strangely an incredible amount of sun. If you'd like to stick around and have a chat, I would love to meet every single one of you, although it would take a while. Please do keep in mind, if you're interested in giving a lightning talk, we will be doing that on the 10th of July. We're going to send out an announcement very, very, very shortly. Please join me one more time in thanking our two wonderful speakers, Esdras and Stephen. Thank you very much, guys.
Thanks very much.